Hello, my name is Ethan Hosford, and I am the team leader for Group P of the AEV project.
My name is Nick, and I was the CAD technician.
My name is Philip, and I was the program analyzer.
My name is Matt. I'm the program editor.
The concept for the AEV dates back to around the year 1930 when engineer George Binney designed the railplane. The railplane was a form of rail transport which moved along an overhead rail by way of propellers. Our task is to use the basic idea of the railplane to design and build an AEV to complete a given mission. In order to save the galaxy from the Galactic Empire, R2-D2 units had to be created to assist in the battle. Since the rebel forces had minimal energy and materials, it was essential to create a vehicle that would move R2 units at a low materials cost as well as high efficiency.
The goal of the AEV project is to create an AEV that travels along a track, stops at a sensor, waits for the gate to go up, bypasses the gate, continues on, stops, picks up an R2-D2 unit, brings it back towards the gate, activates the sensor, lets the gate go up, and return the AEV to the starting point. The goal of this project is to complete that task while maintaining efficiency and reducing energy of the vehicle.
The first step we took was to sketch individual ideas and take time to discuss the advantages and disadvantages of each design. Once each member felt that their ideas were heard, a group consensus was made and 2 AEVs were drawn. Our next step was to build the 2 AEVs that we had drawn, write some preliminary code, and compare the 2 vehicles. We built both a vertical and a horizontal AEV. Through the process of project screening and scoring, we were able to narrow our test AEV down to one design. The design we chose to continue was the vertical design due to the better balance and a slight design flaw in the horizontal design. After deciding on the vertical AEV design, further testing had to take place in order to determine where the AEV could be improved. One initial problem we had was that the propellers were positioned too high on the AEV, so they collided with the track when in motion. This problem was solved by simply moving the motors down a peg on the AEV. Later, we noticed that our magnet was positioned too close to the Arduino. In order to fix this problem, we changed the position of the wheel arm, battery, and Arduino, while maintaining the original vertical design and keeping perfect balance on all axes. One recurring issue we had was that as each lab period went on, we had to change the absolute and relative positions by a few marks to account for the depleting battery. To account for this, we used the same code at the beginning of every single lab and made small adjustments as necessary as time passed. Once we accounted for all the errors, we began to finish the original code as well as work on a completely different code. The purpose of having a different code was to attempt to have a better, more energy-efficient run. We attempted to write a code with a loop for every time the AEV would start. The idea of the loop was to find the lowest motor speed at which the AEV would run. After running this code, it was determined that it was not at all energy efficient due to the total time that the motors were running. After much trial and error, the final AEV was a success and completed every task without fail multiple times.
In conclusion, the vehicle only weighed 220 grams while maintaining durability, balance, and consistency amongst the track. The process for the AEV project assisted in keeping an organized schedule, completing tasks by given due dates, working as a team, as well as completing and implementing the design process. In future endeavors, these skills will be transferred to the workforce. By applying these skills, it is our hope that we will be as successful as our AEV project. Thank you for listening to our presentation. Again, my name is Ethan.
I'm Nick.
I'm Philip.
I'm Matt.
Signing off,
Go
Bucks.
Bucks.